Hello. For our ES116 project, we have built a gesture to text to speech converter glove. We built this project because deaf and mute individuals face significant challenges communicating with general population due to lack of accessible amenities. So, we aim to establish a correlation between specific hand gestures and specific resistance levels by utilizing the flex sensor's ability to change resistance when bent. For this project, we have used 4.5-inch flex sensors, Arduino Uno, HC05 Bluetooth module, which is used to establish a connection between Arduino Uno and the app, and a glove.
I need help. I need help. I need food. I need food. Peace. Peace. Washroom. Cat. Super. Rock hard.
To understand how a project works, it's important to understand how a flex sensor works. So this is how a flex sensor looks like. It is a thin conductive strip which has variable resistance. When bent, the resistance increases. When the resistor or the flex sensor is flat, its resistance is about 10 kilo ohm. And when bent, it varies from about 60 kilo ohm to about 110 kilo ohm. A flex sensor has three main components. These are the segmented conductors, the phenolic resin, and the conductive ink. The sensors we have used are 4.5 inches.
So we see that when the index finger is resting, the value is around 5115, and now we see that when the index finger is bent, the value is around 4640. So we have set the threshold for the index finger at 4800. When the value is below threshold, the finger is bent, and we have set the output for that to 1, and when the value is above threshold, we have set the output to be 0, and we have done this similarly for all the fingers.
So this is the basic circuit design that we utilized in our flex sensors. This is a flex sensor. It is connected to, one of the terminals is connected to a jumper wire which is connected to the ground. The other terminal is connected to one jumper wire which goes into the analog input of the Arduino. It is also connected to a 10 kilo ohm resistor, which in turn is connected to the 5 volt power supply. The reason that we have designed the circuit like this is because the Arduino cannot measure resistances directly from the sensors, and it can only detect change in voltages through its analog input. So this is a voltage divider circuit which can be compared to a voltage divider circuit consisting of two resistors, R1 and R2. In this circuit, this resistor can be considered to be R1 and this resistor or flex sensor can be considered to be R2. We are measuring the voltage output across the flex sensor. We know that the voltage across the flex sensor will be considered as Vout equal to Vin into R2 by R1 plus R2. So this is our final project. We have attached one flex sensor to all the fingers except for the thumb. The reason we have not attached a flex sensor to the thumb is because the flex sensor length is very long and it becomes difficult to take readings in this situation. We can observe that all the flex sensors are connected to each other via a breadboard. Where this is the connections to the Arduino ground. This indicates the connections to the 5 volt. And these are the inputs taken into the Arduino. We have also attached a Bluetooth module to collaborate with that.
Now I shall explain about the working of a Bluetooth module and app. So here for our project we have used the HC05 Bluetooth module, which is designed for wireless communication. This module acts as an interface between our Arduino and the app. We have used 4 pins: RxD, TxD, ground and VCC. The RxD pin is connected to the TX pin of the Arduino. So what happens is that the Arduino transmits data through the TX pin, and it is received by the Bluetooth module on the RxD pin and transmitted through Bluetooth to our app, which then displays whatever sign from the flex sensors. When the Bluetooth module is not connected with the app, we see that the LED continuously blinks. Now let's connect it with the app. So we see that the app is connected when the Bluetooth, when the LED stops blinking. For our app, we have built a simple app using MIT App Inventor. So this is how the interface looks. And to communicate with the Arduino, we have a simple code here, which basically receives the data from the Arduino and converts it into text to speech.
Some of the future aspects that could be incorporated into our project are more gestures using more sensitive flex sensors, so we could try and emulate actual sign language. Another thing that we could do is add a protective casing over our flex sensors, as flex sensors are very delicate and are prone to break.